Recording is in progress. Good evening, y'all. This is Code Platoon, the evening and weekends course. This is Foxtrot Platoon, the best platoon to ever grace this program. If you're watching this, you're probably not Foxtrot Platoon. I don't know where I'm going with that. Today we'll be doing SQL queries, group by and inner joins. SQL is a way to query a database or inject data directly into a database or build a database. It's the language of databases for Postgres. This syntax is pretty similar to some other really popular ones. MySQL is fairly similar to Postgres, but not similar enough that you could just jump on one and know it. Ideally, we teach you enough Postgres that you could probably look up how to do X thing in MySQL that I did in Postgres. And Postgres is a good database to learn because it's very popular for rewrite operations. And we're going to be building applications that are fully CRUD oriented, right? You're going to be creating, reading, updating, deleting. So having a PostgreSQL database is technically the smart engineering answer, even though you're not going to be doing nearly enough like data writing to be pushing the limits of what other database options could provide. But as we did yesterday, we're going to be utilizing the CARS database that's built in this Docker container. As a reminder, just to reorient ourselves, we've got a user profile and an app user. Might confuse you at first, but this is a fairly normal thing. It's a very normal structure where you're going to have a user profile, which is kind of your base stuff, like your name, phone number, junk like that. And then you'll be associated with the application statistics itself. You may just not want all of these things in one table all the time. From there, we've got an advertisement. An advertisement will have an app user. Not all app users will have an advertisement. An advertisement also will have a car. These are car ads. Not all cars necessarily have an advertisement. You can see because advertisement has an ID of an app user, an ID of a car. It needs those things. Car already has car ID. It doesn't need to borrow that from the advertisement. The advertisement does not decide what the car ID is. But a car will have a model ID that links to a car model. Tell us a little bit more about the car. Nothing crazy, just make a model. Kind of what's going on here is you're going to have unique car models and not so unique cars. That's why you want to break those out. As a refresher, I did this. Oh, I'm going to lock my cat out. He's attacking the dog. You must clone down this repository, Docker build, this CARS database, and then run the image. Once it's up and looking good, you should be able to witness it with Docker PS. I've got some other ones running, but there is what we're looking for. To get in there, to jump into a Docker container, you have to docker exec-it into it. You could look it up and then copy paste it. Oh, and by the way, bash is how you'll be interacting. So, if we want to hop in there, we could do that like I just did earlier. And you could copy it and then you could paste it into here. Or if you're a super smart developer, oh wait, shoot, that ain't even gonna work. I'd have to get the first one. Let's turn that off. Let's turn that off. What's that taking so long? There we go. Cool. So now we just got the CARS DB running. What I was saying We've only got one here using some fairly not that complicated bash commands. I could pipe in Docker ps-q, which would get us in there. By the way, so you know what I did, Docker ps-q is quiet, just give me the IDs. I don't want all that other junk. I only had the one there. So Docker ps-q is equivalent to this, which is equivalent to an ID. So I can just feed it directly in there like this if you only have one running. If you've got multiple running, you're going to have to do a little bit more complex bash to figure out exactly which one you want. But this is good enough. And I'm in. From there, we can interact with junk if we'd like. You can sign in directly. We're now in. And here's a database full of tables and such. It should be populated because oh, that's a big file. I didn't really want to open that up. This is init.sql. This is going to instantiate all of our SQL. This is the Docker file. Notice the Docker file literally just stamps this over to here and then runs and does some stuff with it. So that's why our database is already populated. But I'm not going to be interacting with it like that today. I'll be utilizing a script. So let's scroll down a little bit in the cars database, readme, figure out how I'm going to do that. So I built the image, ran the image. This is if I want to, go in and execute queries. I don't really want to do that. I kind of want to run a SQL script. So you need to make sure we are running, which we should be because we ran it up here. Oh wait, no, I do need to. I think I need to do this. No, that's the same command, isn't it? I need to establish a port. Let me. Not sure if I need to start it before stopping it. Stop it before starting it to run this again, but I'm going to do it anyways. Start that up. Now paste that in. Stop that. Start it up. All right, there it goes. Now you can interact with it by. So what we've done here is set a port of 542. We're basically saying localhost, hey, you're going to feed directly into this Docker container. That Docker is going to be named runner. Remove it if there's another one. The Postgres password is going to be password. So I can run a Postgres QL command because this Docker container is running. It would connect to my local host. Here's the host, local host. Here's the port 5454. User Postgres -d cars. This is going to get us into that table. Blah 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 blah. -f script. Fun. But it's going to queue us for a password. So we can feed it a password via the environment variable here. You can do that before every command. You also, in this current script, if we don't want, we just want this to last for now, just until I kill this with a Control D, that'll kind of stick around now. See there? Only if you want to futz with all that. So instead, we really just need kind of what we had above. And we'll run this car script. Did I open it to the right thing? Oh, get out of here. Oh, goodness. I'm sorry. I don't know why this didn't drop me off where I got off. Well, that's all y'all's exams. You want to see that. All right, back to sanity. All that because I just wanted it over here. Sorry, I wanted my tree. This is the script I ran. Select star from car. Get out of here. All right, there. List of cars. We selected all from the cars. We got everything for the cars. There, we're ready to start the lecture. Get out of here, you're not helping. Okay. Any questions about how I got that database running, how it's running now, how I'm interacting with it, how I intend to do this lecture? It might be review, but I have a feeling a lot of y'all wouldn't be able to talk through all of that without a quick refresher. I know I couldn't. Okay, now we'll actually do our queries. So in addition to what you already know, we're gonna add some new stuff. These, this is group by. So SQL is going to be querying a database and visualizing it for us in the terminal, and we'll be getting tables, terminal relational outputs of what the table is, but we can kind of decide what that looks like. We don't just always have to get all of this junk because there's a lot of cars. I can kind of go and hold this down for a good long time. I forget how many there actually are, but this isn't very useful. Nobody wants to sit here and read all of this and look at the IDs and try to guess the different dates and times and all that. We can filter our data a little bit. So what this is going to do, select, and it's going to get a count of distinct models. It's going to find all the models that are distinct from car models. I think all these are going to be distinct anyways. As I said before, car model is kind of a unique database. Let's paste that here in the script. Again, not going to interact directly with the database. I just want to run through a script because I can undo things if I know, I got history here of what it is I actually ran. So cool. I got a count of 99 from the car model database table that just took account of all the uniques from a table. That's just for every one of these, we counted them up, and that's what we outputted. We didn't have to get make, model, car model ID. I didn't ask for any of that. I only selected a count instead of a star. What if we want to get the count of models per make? Well, let's paste this in here and talk about it. So I'm going to select count star. Actually, let's compare that to what we ran the first time. Select count star. This is going to be get all of them. I don't need, specifically, I'm not referring for, or I'm not asking for uniques. And I want the make from car model, group by make. What does that mean? From car model, all right, I want to count them all, and I only really want to see the makes. Group them by make. Let's see what that looks like. Hey, that's some useful information, huh? For every model, rather, model is not the word. These are all the makes of the cars. There were 2 Lincolns in that database, 2 Fiats. But this is also not super great. Look, 2, 2, 4, 3, 5, 3, 5, 6. This is just listing them in the order that they kind of showed up. We can make that a little bit more useful to read. So let's clean that up a bit and order by the count, starting with the biggest. That is going to look a little bit cleaner. So pretty much the same all the way to this point. And now we're just adding order by count, descending. That a little bit more useful. There are 9 Beamers, 7 Citroens. I've never seen this in my life, and I've taught this class before. I never remember that. The rest I don't know what the heck these are. I know where Renault is. Cool. That's what we got in our database. Now, this is, oh, did it want me to do it this way? Oh, that's right. All this is showing you, by the way, is you can do line breaks here. Much like JavaScript, it doesn't care about anything that isn't spaces and semicolons, right? So I could do some really dumb stuff like this if I really wanted to, and it wouldn't be that upset with me, I don't think. Of course, don't do that. Keep it nice and clean, but this is a heck of a lot more readable, right? And if you wanted to, you could indent things, to kind of make it make more sense to you. You could split it up if you would like, if you had multiple, kind of columns to read. So now I can see, hey, this is what I'm going to be giving myself. These are going to be my, columns. This is the database I'm getting it from. And this is how I'm going to mutate the data. Just showing you, you can do that. You can make it more readable for yourself. You don't need to go, turn this in to your boss and have multiple lines wrapping around and doing all that. You can break up SQL. The only thing it cares about is that the verbs go in the right order. They don't even have to be uppercase. They can be lowercase if you want, but don't do that. It's easier to read this way. This is more conventional. You understand what the verbs are. You're not going to get confused with these other columns. The order you invoke them in, if you're using commas in the right spot, and wherever that semicolon is. I'm sure you've run into it. If you're interacting with the database directly, you hit enter and it just hangs and it's waiting. It's because you didn't put your semicolon in there, just like JavaScript. Again, I'm not fighting that. I'm not running into issues with it. I've got a script. Oh, it didn't even fight me on that. Okay, because I'm doing it in script, it's fine that it ended. It was the end of the script. But if I had another command, it would probably get mad at me. Yeah, see, they're not happy. Line 2. You can't have a select after another select. It's because it expected a semicolon there. Now it's fine. I blasted through that a little quick. Y'all understand you can line break as much as you want on SQL, tabs, spaces. Sound good? All right. Filtering by group by is a little odd. Let's say we want to get the count of models per make, but we only care about the Volvos, Fords, and Kias. You might expect it to look like this because you've used where before, but this is where we're going to shift it up on you. Where doesn't work when we're grouping by. You got to use the word having. Sorry, I added a new verb to the game. Can't use where when you're looking at a group, or rather when you're grouping it up. It wants to see the word having. So, I mean, you can try that. It will give you a syntax error. Let's do the right way. Select the count of the makes from car model, group by the make, and then they have to have a make that is Volvo, Ford, Kia. Let's see what that looks like. Nice and clean, easy peasy. Getting SQL queries right feels really good sometimes. This is about as close as we're going to get. Well, not as close, but this is fairly close to data science, I guess. Looking at big data and figuring out how to filter through it, break it down into something that makes sense. There's better tools than raw SQL, but at least in my opinion, it feels kind of good to take a big jumbled pile of cars with random information and then spit out something that is useful, right? This may not be human readable to everybody, but this is not super hard to read. You can kind of run line by line. And if you want to, oops, you can add comments. This is the database. Just whatever you want to do to make it easier to understand and read. Joins. We've got separate databases here. Or sorry, I really throw that around wrong. These are tables, not databases, Jordan. This is all one database, different tables. We don't just have to look at one time. We can associate them with each other. Just because they're not, they are connected a little bit here, but we can kind of build our own outputs based off of matching parameters on these different tables. There are not a lot of developers out there that can tell you the difference between inner, left, right, and full. they only ever use enter. It's not complicated. I'll explain it here. We will just be using enter join, but I'll talk about it. So a join can allow us to support a pretty common use case: retrieve users and their advertisements in a single query. Let's run it. Show you what it looks like, and I'm going to talk about the different types of joins. I know I'm seeing like I'm skipping it. I'm not skipping it. We're coming back. Select all from app user, inner join, advertisement on app.user account ID equals advertisement.seller account ID. I just want 5. What we have done is we have taken the first table, app user, inner joined it, meaning only where things line up in the advertisement table, and wherever these are the same, I want to see the rest. I want you to smash these tables together, which is what we've done here. So app user has, make sure it's all here. App user has account ID. We're saying that's the same as seller account ID. We really should only see it once. Account ID. Oh no, it does tack it on there at the end. We can do stuff about that. So first name, last name, email, password. Also, advertisement date, seller account date, or ID, car ID, advertisement ID. It is all here in a big old table. So, inner join. It's going to, for every table over here, or sorry, every column over here, where these match, it's going to bring over the advertisements that match. A left join is going to return all rows from the left table matching the right. Which one's the left? It's the first one. Don't let the left, right, whatever mess with you too much. The right is the second one. So if we were left joining, we would be returning all rows from the app user and matching rows from the right user. So we're going to get all of app user and then only the matching rows from advertisement. If it was right, we would be doing all of advertisement and only the matching rows from left. So if we were to left join this, we would probably only get everything up to here. And then we would see seller account ID, I think. What? I messed that up. Did I lie? Why are they smushing? Oh, because I'm selecting all. Jordan, you're dumb. We're going to keep moving. It's going to show them all the time. We'll get into it more. That's what I get for going off script. Oh God. Okay, so these next few lines, we're all kind of saying the same thing. We talked about what this is grabbing. It's going to show us all columns. This is going to be the first table. This will be the second table. This is what we're matching on. Some bit, okay, it breaks it out a little bit more than we need to go into it. Something I do want to point out, which is here, is you see how we're calling the first table app user dot account ID to try and get this account ID. Sorry, this account ID. Well, we don't really have to do that because advertisement has a seller account ID. So we got account ID and seller account ID, meaning you don't have to be that specific. You only need to fully qualify it if it's not unique. If seller account ID over here was just account ID, which would be fine, that's not weird, then you would want to fully qualify which table it's coming from. Otherwise, it's either going to blow up on you or it's going to grab the wrong one. So if that's what the actual, name of it was, then this would be totally necessary. It's not, you don't have to do all that if you don't want to. Keep your SQL small. This will still run and look the same. Does that make sense to everybody? The prefix, not necessary unless these aren't unique. Note that an inner join will only return rows where there is a match in both tables. For example, if there is one user who has placed no advertisements, Janie Biddy, you can see she doesn't come up in the above query. All right, so we expect to not see someone here. Let's run it and we'll talk about it. Select all columns from the app user, inner join on advertisement. This is going to be, like we mentioned, account dot or app user dot account ID, where that lines up with advertisement seller account ID, where app user dot first name is Janny and last name is Biddy. No response. That's because this doesn't exist. There's not an app user dot account ID matching an advertisement dot seller account ID. And we can go find old Janny Biddy. I think. Janny, you better show up in this database. I know you're here. No. Let me search the file. Oh, there's a mistake in the curriculum. I did that. There. Cool. So this account ID of 481, Janny Biddy, this person doesn't exist in the advertisement table, is all that's saying. If they did, we would find them. Let's look at one final example. So let's get the number of doors for every make and model. And this is going to be a little bit more table manipulation and then kind of some shorthanding. Again, just throwing examples at you so that you can look back when you need to and find good ways to query. So reading it left or right, select car model dot make. Again, we're fully qualifying this. We don't have to, or do we? Yeah, we really don't. See, because car model has a make and a model, but the car does not. So if you wanted to, you could strip these off. You don't have to. Car, number of doors, yep. And we'll leave those alone, see if it jacks it all up. Hey, look at that. Didn't blow it up. Does that look like the output I'm supposed to get? It sure does. So we wanted these columns, and these are the three columns we got: make, model, number of doors. We took it from the car. Oh, car joined car models. These are all we want to see on car.car model ID, car model.car model ID. That's going to get old reading all the time, but that's what we're doing. We're matching it on the IDs. This is often how you associate tables to other tables with a relative database. So you're going to be matching IDs. And we want to see the top 10. And that's what we got. The make, model, number of doors, the first 10 make sense. Sort of weird thing to look up. No, this is a separate one. So let's say you want to get the distinct names of anyone in New Orleans, place an ad in May of 2014. This is getting to be fairly complicated, but when you work with SQL, kind of just build these up slowly. We would start with, let's just do it. Actually, I don't really like that. We've got this ahead of this one, so this one's a little bit more readable. The other one's, this example is shorthand, which we haven't talked about. If I were to build this out, I would kind of start here, right? So select distinct user profile dot street name, and then we would, of course, have to give it a database. But that's probably where we'd stop. So we can get every distinct street name from the user profiles. But we want to associate it with somebody, you know, not, oh, did we run this properly? There we go. So we got the street name, but we need to associate it with ads that were placed in May of 2014. So we need to associate with app user, because that's how we would get the advertisements, right? User profile over here, advertisements over here. We need to associate user profile to app user to get the advertisement. So we're joining app user on app user.account ID, user profile account ID here. And then again, we're going to join advertisement. So we've taken user profile, we've slapped on app user, and now we're going to slap on advertisement, where we've seen this before. Account advertisement seller account ID is equal to the app user account ID. Again, we're just joining this table to this one based off this ID. And then we're taking those two we've built, joining them together again on the ID. And like we said, where, because this is in a group, we're using where instead of having user profile.city is equal to New Orleans. This extract bit here, not common SQL, but we're showing you it's there. There are a list of interesting SQL built-in functions that you can utilize, which you should at least familiarize yourself with a few of them to kind of save yourself some work. Oh, done that. What?
Semicolon line 2.
Yeah, I got rid of it, didn't I? There we go. What the heck does Hamilton Street mean? Anyone in New Orleans who placed an ad in May of 2014. This is the street they're from. Weird thing to look up, but we did show you how to get from A to B to C. Yeah, that's a weird way to go about it. The only other example is kind of the shorthand SQL, the new hotness in SQL, if you will. We didn't have to type this out because, again, street name is kind of only associated with this one table here. But we put user profile to fully qualify it. We could, this kind of just, this is how you build a variable for that. So instead of using user profile every single time, using the power of Visual Studio Code, you can see there's 4 uses of it here. I can say from user profile, which is P now, meaning I don't ever need to use the full user profile again. This is handy because remember I said we don't need to fully qualify it. Well, we do now because account ID exists in user profile and account ID exists in app user. So we can't just say account ID. We have to refer to what table it's coming from. If you want to shorthand that, when you're saying which table you're getting it from, if you just put a space and any kind of variable you want, it could be anything, right? This will still work. all the dot P's, foo, dot, right? That'll still work, but let's not overcomplicate it. You can change it to whatever you'd like it to be. This is setting a variable in SQL. And again, oh, I'm messing with the wrong one. Samples down here. So user profile is P, and then app user, we could say that one is, for instance, A, just like we did down here. Everywhere else we're seeing the word app user, we can replace that. You really wouldn't be replacing this so much as typing it out as you go, but I want to show you at least, how it was thought of. And then advertisement, AD, you can write whatever you want. So a little bit shorter hand, a little bit easier to read. If you find that distracting, you don't have to do it. You've seen that it works without kind of shorthanding it, without using variables. But this is a common convention that I'd like you to at least know how to read. I don't want you to get to this line and say a.account ID. What the hell is that? It's established right here. Any questions about any of that? Don't worry about left and right joins right now. I realize that's a later lecture, and I shouldn't have tried to jump into that with this one without examples loaded up, ready to go. Probably should be pushed into this lecture, which I will make a note to do now that I think about it, because we're supposed to be short in the SQL lecture. Questions about this lecture and not the tangent I tried to walk off on?